Welcome. In today's class, we will look into vector addition. In vector addition, we have two laws. We have triangular law of vector addition. We have parallelogram law of vector addition. Let's start from triangular law of vector addition. Triangular law of vector addition states that the sum of two vectors moving on the same kind, represented by AB and BC, is the vector AC. Let's draw a triangle so we can illustrate the law. We have A, we have B, we have C. Now, the triangular law of vector addition states that the sum of two vectors moving on the same kind, this one is moving like this, it can turn and move like this, is not opposite direction, is the vector what? AC. Now, this vector, remember you say is vector AC, that a vector represented by AB and BC is the vector AC, which implies that vector AB plus vector BC from definition is equal to vector AC, which we can see that AC is equals to, AC minus AB will give us BC. The same thing, AC minus BC will give us AB. Now, if we represent this AB by small letter A and represent BC by small letter B, AC will now be A plus what? B. A plus B. Now, this A plus B is called the resultant vector. This A plus B is called the resultant vector. That is, when you add two vectors to get this, it means the resultant what? Vectors. Under addition, let's see the one of subtraction. Having a triangle like this, now let's go here, vector A, let's name them A, B, and C. Having a vector A here, having a vector B here. Now, if B is here and this one is moving in another direction, it means that here is minus B, because it is in our, if you check our episode 1, we talked about negative vectors, vector having different opposite what? Direction. They have opposite direction. So, let's check this now. A coming down here to move this way in the same sense, it will now give us A plus B. Now, A coming down to move in this sense, here will now give us A plus minus B, which implies that vector A minus what? Vector B. So, under this triangular law of vector addition, it simply means that sum of two triangles moving in the same sense, their sum will give you a resultant of the other what? Vector under triangle. Parallelogram law. Now, parallelogram law of vector addition states that the resultant of two vectors, is represented by the diagonal of the parallelogram whose adjacent sides are the two vectors. Let's draw a parallelogram. Let's draw a parallelogram. This is a parallelogram. I'll give them alphabet. Let's start from here. A, B, C, D. Now, this is adjacent side. Let's call this adjacent side A, vector A. Let's call here B, and let's call here. Now, remember parallelogram. Properties of parallelogram. Opposite sides are equal and parallel. When the opposite sides are equal and parallel, and if you watch here, the sense are moving on the same direction, which means here is equal to this place. Here is also vector A, and here is also vector B. Now, from the state of law of vector addition under parallelogram, it states that the resultant of two vectors is the diagonal of the parallelogram whose adjacent sides are the two vectors. Now, this is the diagonal. Let's say this is the diagonal. Now, this diagonal will be now A plus what? B. Will give us A plus B. Now, let's check it. Let's check it. You can see that this thing, because if you divide a diagonal into two, you have two triangles. You can see that both triangular law of vector addition and parallelogram law of vector addition, they are talking the same thing. Now, let's see from the law, two adjacent sides. If vector A now, this vector A plus vector B going this way, coming back this way, it forms A plus what? B here, which we can call this A plus B vector what? C. In the same sense from here, vector B plus vector A coming back this way, remember addition is commutative, is now what? A plus what? B here. So, almost parallelogram law of vector addition and triangular law of vector addition is almost the same thing. But there is something I need you to watch out from parallelogram law of vector addition. Remember we said that AB plus BC is equals to AC. That is AB plus BC is equals to AC. Also know that AD plus DC is also equal to AC. Also note that AB plus AD is also equals to AC. Watch it out. AB plus AD. What is AD? Our AD is the same thing with what? BC. Because opposite sides are equal under parallelogram. Properties of a parallelogram. So this AD is the same thing as what? BC. So we can say that AB plus AD will give us what? AC. The same thing applies here. That BC plus DC will still give us AC. BC plus this DC will still give us what? AC. BC plus DC will still give us AC. So we can have something like this. We can have something like this. Let's call here O, moving like this, a vector moving like this, and a vector moving like this. Now there is another one at the center coming out. Let's call here A, let's call here B, and let's call here C. Now from this, we can state that A plus B is equals to what? Vector C. Because if you watch, you can see that this forms a parallelogram. It forms a parallelogram. So we can say that vector A plus vector B is equals to what? C, from this parallelogram law of vector addition. Suppose there are two or more, let's say there are more vectors, like two or more vectors to be added. Triangular law of vector addition can also be used to achieve that. Let's see. Let's say we have an origin O and we have a vector. Let's say we have a vector. We have another vector. We have another vector. Another vector. Another vector. Let's stop here. And this vector moves like this. This vector moves like this. Now, let's go here O, P, Q, R, S, T. Now watch this. Note that all vectors are coming out from the origin. All these vectors are moving out from the origin, which is all these vectors are called position vectors in our last class. So if this vector moves like this, from here now, we can use triangular law of vector addition to add them all. Because if you watch carefully, you will be seeing triangles. You'll be seeing triangles. That is, we can now say that OP plus PQ is equals to OQ. Now, OQ plus QR is equals to OR. OR plus RS is equals to OS. OS plus ST is equals to OT. This is for vector addition. You can see moving from O to P, P to Q, coming back like this is a triangular law of vector addition. Now we can also say that now this one is adding 2, right? Let's see how we can add everything. Now we can say that OP plus PQ plus QR plus RS plus ST is equal to OT. So we can use triangular law of vector addition to add two or more what? Vectors. Two or more vectors. From here, we can go like this and add everything since they are moving on the same sense. They are moving on the same sense. Till coming back, they meet this guy coming out. So the addition of all this will give us what? This. If you take them 1, it will be going like this. Because if you watch carefully, this plus this gives you this. This now, which is these two things, plus XQR give you this. This one and this OR, from this OR is addition of everything up here now. OR plus RS will give you OS. OS plus ST will give you OT. This is all about triangular and parallelogram law of vector addition. Let's see more examples on this. Now, example, if ABC is a triangle, what is the sum of the vectors represented by BC, CA, and what? AB. From the question, you know it's a triangle. You draw a triangle. You draw a triangle. Now, you give them alphabet. From here, we have three alphabets, A, B, and C. Anyhow you start it, you have no problem under triangle. Anyhow you start it, it must still correspond with A, B, C. Now, we say that the vector moves from B to C, B to C. The vector moves from C to A, C to A. The vector moves from A to what? B, A to B. Now, the question is, we should find the sum of the three vectors. But from the law of triangular vector addition, from the law, it states that AB plus BC will give us a what? AC, right? From what? From the law of triangular law of vector addition. Coming back to this question and going back to our previous question, that is vector under episode 1, we say something about negative what? Vectors. We say something about negative vector there. Let me do it again. That if that negative vectors are equal, not they are equal, not although they are equal. Like if we have something like this and we have another one moving like this, let's call here AB. Yeah? And here is still what? AB. Under the negative vector, we say that the magnitude of A, B, remember they are moving from A to B in this one, is equals to negative of BA. Remember that this vector is moving from B to what? A. So this AB is equal to minus BA. Now, coming back to this is the law of triangular law of vector addition. And we have this question to solve. And if you watch, A plus AB plus BC is not corresponding because this sense supposed to face this way for you to prove this law right. But no problem. We can still do it by saying that AB plus BC is equal to minus CA, is equal to minus CA. Obey that rule. Obey the sense because the vector is moving from C to what? To A. But the outcome now will not give us positive answer. It will give us negative answer because it is moving on this sense. They are not meeting at all. You can see it. They are not meeting. If this sense moves this way, they will meet and we have something like this. But it is moving this way. So they are not meeting. So we have to be what? Negative. Now, since it is negative, because remember the question says, what is the sum of the vectors represented by this? We have to add them together. So we have vector AB plus BC. This one comes inside, turns to plus AC MCA, which will give us what? 0. That is the addition of these vectors will produce what? 0. Here is where we're going to stop today. More examples on triangular law and parallelogram law of vector addition is coming. Thank you.
Yeah.